Okay, so here's a couple of log graphs from from section 4.5 on page 307. And I thought I'd walk you through my how I do these kind of problems. So what am I noticing here for this number 19? Remember, these odd answers, or you can find the fully worked out answers online. So I've got that information in the week 0 area. So I'm seeing a log graph that's been shifted to the left 4 units. So I know a log of x plus 4. Remember, when we do those transformations, it's opposite. When you go, the left-right shifts are always opposite because of the general form. And then plus some constant. I don't know if this function's been shifted up or not. And I'll put a y equals just to. So then I'm going to pick a point. Looks like -3, -3, 0 is a good point to use. So it's a nice lattice point. So y is 0. Because I've got a couple of variables here I got to try to get rid of. That a, I get the k, I got to see what they are, or if they're 0, I want to be able to eliminate them. So plus k. And let's see what's happening here. Well, -3 plus 4 is 1. And the log of 1 is 0. So that tells me k is also equal to 0. So there's no vertical translation here. So that I can forget all about. I don't have to worry about that part. So let me delete that. So it's not in my mix. But I had to rule it out because sometimes they do shift. And then we got to find another nice lattice point. Oh, I don't know. I'm looking. I think, let's see, let me get in my pointer going here. I think this is the lattice point. That's close, but this looks like it crosses a little bit better. So that's the point I'm going to go with. I'm going to go with -1, -3. So let's see, where's my pen here? So -3 is the y, equals a times the log. I don't know why I put a parenthesis there. Log of -1 plus 4. And then we know k is 0. You know what I'm going to do? I'm going to get rid of that extra parenthesis that I inadvertently put in there. So -1 plus 4 is 3. So -3 equals a times the log of 3. So a has to equal -3 over log 3. So, so it could be done at this point. I could say, well, let's go back up here. We know the k is 0, so that's gone. And I just found out that a is -3 over the log of 3. And that'd be a perfectly acceptable answer. My open math would take it. But this double log sometimes can confuse people. So one thing you can do is think, well, let's see. Can't I rewrite this? Because this is just multiplication. Can I think of this as -3 times the log of x plus 4 over the log of 3, and that looks a lot like the change of base formula. So that we can think of as -3 times the log base 3 of x plus 4. So that's another way to write this solution, and it's actually either one is correct. I don't usually do this step. I'll often just leave it this because why do more than I need to? But it does kind of clean it up, make it look a little prettier. Okay, now I could have done this with base e. It just wouldn't clean up that well. I mean, because if I had done this with base e, let's see, the person that I'm writing this video for did do that. I don't know when you're going to see this video. So what that person chose to do is say, okay, so I got y equals a times the natural log of x plus 3 or x plus 4. but I didn't. I just realized I did that plus 3. I hope I didn't do this in all my earlier work, but I didn't. So x plus 4, because that's the vertical asymptote. And k will be 0. There won't be an up-down shift. If you use that same point, negative, what is it? Negative 3 is y equals a times the natural log of, let's see, negative 1 plus 4 is 3. So that would give me a equals negative 3 over ln 3. And of course, if I try to clean up negative 3 ln 3 times the natural log of x minus 4, that I can't use that change of base. Excuse me, that change of base formula just doesn't work out so slick. Well, I guess I could, but it would change it to log base. It would change it back to what I had here. So what am I supposed to be writing here? Plus 4. So that'd be another way to do it with natural log. And both are correct. You know, one's not any more correct than the other. Okay. So that's question number 19 on that page. What if you take a minute here? What can I do? What if you take a look at number 20 and stop this video and you try to do this problem, and then you can come back and finish watching the video and see what I do to get this answer. Okay, so what I'm going to do is, I notice there's a vertical asymptote at x equals negative 3, so I know that y, or f of x, equals a times log of, let's see, x minus 3, so I'm going to write as x plus 3 plus k, and then I'm going to use that negative 2, 0 point, which probably is going to tell me k is 0. So I'll do it just to go through the motions, but I'm pretty sure k is going to be 0. So it's that log of 1, negative 2 plus 3 is 1, plus k, and same deal. We know the log of 1 is 0 times that, so k is 0, so I won't even go any further. I know k is 0. And then let's find another point. Let's see, another lattice point. That's looking like a lattice point to me. So what's that, 3, negative 3? So I know that negative 3 equals a times the log of 3 plus 3. And I know k is 0. So won't that become negative 3 over the log of 6? Because 3 plus 3 is 6, and I divided by the log. So that would give me a solution of y, or f of x, equals negative 3 over log 3, or log 6, times the log of x plus 3. Now I was trying to think, could I clean this up? That log 6 seems kind of large, and it's a 3 on top, but I know that 3 times 2 is 6. So I could think of that as log 3 plus log 2, but I can't cancel anything out, so I don't want to do that. I mean, that's just making it look a lot more complicated than it was. So I tried it. Sometimes, like if you have log 9, you could certainly clean that up, but let's see, where's my delete? So that's an answer there. I could also write that as let's see, negative 3 log base 6 of x plus 3 would be another solution. Now, I haven't been checking these with Desmos on a test situation. I certainly would. I would plug that into a graphing calculator and make sure that those points match up to the points that I chose here. Okay, so hopefully that helps you write log graphs. I mean, something I'm going to ask you on the next exam, and I think it's an important idea to get you ready for calculus. Okay, I'll stop the video.